Okay, let's get started. Are there any questions? Yeah.
Yeah, so can we come to you for help, like on the homework at the office hour?
Absolutely not. You can never ask me any questions whatsoever.
That's sarcasm? No.
I fluently speak sarcasm. Yeah, of course.
All right.
Yeah, absolutely. In fact, I encourage you to if you have, if you.
All right, I'll see you later.
One of the hardest things for people in intro programming classes about assignments in programming is getting started about the assignment, not knowing what to do at the very first step. And so then they just put it off until right before the deadline, and then everything blows up, obviously. So if you want to try to avoid that, try to get help as early as possible to try to get started. Once you get started, it gets a lot easier. The hardest part for most people is getting started. Other questions? Way in the back. Yeah, so I kind of screwed up on the lab. So you're supposed to be using if-else statements, and I'm going to try to get to that today. It won't happen again. So. So if you're in that particular situation, what should you do? Okay, or go to office hours, or yeah, tutoring is a good resource also. Other questions? Yeah. Guys, shh. Yeah. So I've addressed this in class multiple times. So if you have any of the days that there's no lab or the university is closed or whatever, you can go to the other ones if you want to. You're not required to. We'll still count attendance. You don't have to submit the lab that time because we count the top 10 submissions of labs. And every single section meets at least, I think, 11 times. So everyone is okay. But you do not have to go to another lab, but you're absolutely welcome to if you want to. Well, they're listed on the syllabus. But note that if the room becomes too full, then the TAs are required to kick anyone out who's not officially registered in that section. So I would highly recommend going to the Thursday or Friday ones because those are not as full. But again, I can't predict what will happen. Oh, there's one question way in the back somewhere. Yeah.
Yeah. Do we have to go to lab to submit or to make credit?
Yes. So 5 points out of the 10 is for attendance. 5 points is for the submission. Yep. Other questions? So lab 1 should be mostly graded. Pretty much everyone did well. I was happy about that. Assignment 1's being graded. The grades so far look pretty good, but I'll let you know what will happen once that is done. And I'll post that on the course page, the distribution. Any other questions? I don't know what happened there. Okay. Any questions though? Okay, so we have a lot to get to today. So last time we were talking about strings, which represent a whole bunch of text, and some things that you would like to do on strings, such as how should you input them? Do you count the spaces, the delimiters, or not? If I want to know the length of a string, then I just call .length on the string. So whatever the variable name is, then I call .length with parentheses, and that's called a method, but we haven't gotten to methods yet. But it'll give you an integer which represents how many characters are in that string. Pretty straightforward. And then we saw another method, assign, which means you put a repeated number of characters in a string, which it could be useful. I've never used it though. Then the last thing we saw was a Boolean type thing, which is a value that can be either true or false. And we'll be, in fact, using Booleans all the time. All right, so just a couple other things before we get into the real meat, which is the if-else stuff. So One thing that I haven't really used, but the people who are in electrical engineering may want to know this, size of, which says how many bytes does a particular type have. So if I want to know how many bytes a float occupies, or how many bytes a double has, or how many bytes an int, or short, or long, or whatever, then this will give me how many bytes there are. So you may want to know, well, how much data, I have this amount of data that I'm allowed to store on this chip, but I can't store too much on it. Then this can tell you, well, what data type should you use if I want to represent all this data on this very small amount of memory? Can I actually fit it in this amount of memory, or am I not able to? So I've never used it, but I know that this is quite useful sometimes. But one that I use all the time is something called auto. So it was actually recently introduced into the language, and it's a godsend in like every possible way. So the reasoning behind auto is, well, there are other reasonings, but one of them is the compiler knows the type of the thing on the right-hand side. Why do I have to retype it on the left side if the compiler already knows it for me? And so basically, if you have something that's like, say, an int on this side, then I don't need to necessarily type int on the left side. So if I have something that's like a long on the right-hand side, then if I just put auto here, then it'll try to represent that as an integer. But if I put the LL, remember the LL suffix at the end of the number, which represents, I want to interpret this as a long, then the compiler will say, oh, the type of this thing now is a long. If I have a string on the right-hand side, auto will say this length variable is a string. Yeah. It wouldn't convert it to a string. I'm not sure what actually happened in that case. So that's a great question. So it's like, if you have something that's too long for even a long, I'm pretty sure the compiler will complain to you that this is too long. But in fact, I am not sure what'll happen. I think that'll happen though. Yeah.
If you define multiple variables after auto, but they're of different types, what will happen?
Oh, great question. I don't know. Let's see. So I have something here. So let's comment that out. Oh, so if you have a whole bunch of code and you select it all, and then on Mac, I'm not sure what you do on Windows. If you do command comment /, it'll comment the entire block for you. So you can comment things out pretty easily that way. So let's see what happens here. Let's say I equals 10, S equals string. So let's just see what will happen in this case. Okay, yeah. So so it has to be the same type if you declare multiple variables on the same statement. Yeah. Great question. I actually didn't know that. So good thing to know. Any questions about auto though? Basically, you're just saying that you have something on the right-hand side. You don't want to retype the same type on the left side. And just makes your life easy. So one good thing about this is, if you could think back to the integer example where it could overflow, then if you put, like, say, a short on the left side, but a normal integer on the right side, then that might cause a problem. But if you put an auto on the left side, then it will always give you the right type of whatever it is on the right side is always the same type on the left side. So there's no implicit conversion that'll happen, and so that would cause some subtle bugs that could happen, but if you have auto, that won't happen. Yeah. Yes, auto will deduce the type of user-defined types, but we haven't gotten to user-defined types yet. Other questions about auto? Cool. So this one is actually something we've already covered. Although it's not completely in full detail here, but scope is basically where the variable lives. So remember when I said that you have to declare a variable before you use it? that's actually called the scope of the variable. So the scope of the variable pretty much is when you defined it anywhere below that. So if you define a variable, right after that, you can use that variable in any way. And so like here, you can see that this statement cout num2 is illegal because I've used it before I declared it. Another way of saying that it's not in the scope of num2. This third statement is not in the scope of num2. And so that's just another way to say use declare a variable before you actually use it. Okay, so comments are actually kind of important, although we've seen that a little bit, but there are other ways we can get comments in the program. So the main purpose is just document the program to make it easily readable to the user. So if you look at programming assignment 2, where you have these bitwise operators, then that's not easily interpretable by a human, right? So if you put a comment there saying, oh, this is what this code does, then now the human can say, oh yeah, I may not completely understand the technical aspect of what's happening here, but from the comment, I can get a general grasp of what is actually happening. And the good thing is that it's ignored by the compiler, so you can type as many comments as you want. It's not going to affect whether your program compiles or not. So the one that we've seen so far is a single line comment. So it's 2 forward slashes, and then anything after that on the same line is ignored by the compiler. It's a comment. So anything after these 2 forward slashes is ignored by the compiler. And then same thing here. Yeah, same thing here. And then you don't have to put them at the end of a statement like this. You can put them on their own separate line, as you might expect. But you may want to think, well, I want to put an entire documentation of this entire program maybe at the very top of the file so that the user doesn't have to look through the entire file. They can just look at the top bit. But it may be cumbersome to say / something, then another / something. What may be useful is a multi-line comment in that case. So what happens here is that if you have a /*, then anything, even on multiple lines, is ignored by the compiler, is a comment, until you see a */. So if you have a line like, several lines like this, then the beginning here, this / starts the comment, and then all of this is ignored by the compiler until I see the */. And then anything right after that last /, then it becomes interpreted by the compiler again. You could have another comment here if you wanted to, but right after here, then compiler's going to say, yeah, I'm going to look at the program again. Okay? You can, of course, use them as single line comments, but there's really not a need to in this case. I would just mainly use these for multiple lines. If you have a long block of code, but you don't want to put a whole bunch of individual single comments, then a multi-line comment is very useful here. Okay, any questions about comments? Okay, yeah, so it should be pretty straightforward. So I'll cover some operators, although this is not an exhaustive list, but the main ones that we've kind of seen so far are the arithmetic operators. So there are different kinds of operators that deal with arithmetic. So one of them you may have seen is if you put the negative sign, that actually is an operator to say we're going to invert from being positive to being negative. So it's called a unary operator, meaning it only has one operand. So in this expression right here, -5, what is the operand? Yeah. Yeah, it's 5. So the operator is the negative sign. It's operating on the operand. So operand is the thing that's being manipulated, and the operator here in this case is the negative sign. But of course we can have binary operators, meaning that we take two operands and apply some operator to them. So in this case, what are the operands in this expression? 13 and 7, right. And what is the operator in this case? The minus sign, yeah. So we can have binary operators. So the main ones that deal with arithmetic are, as you might expect, addition, subtract, multiply, and divide. But this one we haven't really seen yet, and I'll cover that on the next slide. So, so there are binary operators. There's actually, in some cases, something called a ternary operator. This will be basically what will be covered in the next set of slides. What this says is, if x1 is true, so the question mark kind of means if x1 is true, then the value of this whole expression is x2, whatever it evaluates to. Otherwise, if x1 is not true, then x3 will be the value of this expression. But we'll cover that once we get to if and else and all that stuff. But just note that there are unary expressions that operate on one thing, then a binary operators and ternary operators. Although I should mention, although I think I mentioned this one time, something about the division operator. So if you have both operands of a division as being both integer, then we noted that we can't guarantee that we're going to get an integer out the end if we just divide in the straightforward way. So like in this case, 13 divided by 5 is 2.6, but that's not an integer. So the C++ language says, oh, if you have that case, you're always going to round down. You're going to truncate the part that's not the integer. So if I instead had 10 divided by 5, what would the answer be? It would just be 2, right? So sometimes you actually do want this. You do want an integer division, but if you just want the integer part of it. So as an example, if I tell you how many seconds some time period is, and then you want to know how many minutes have elapsed, whole minutes have elapsed, then you just divide that integer by the 60 integer. So what happens is you're not going to get the remainder out of it. You're just going to keep the integer part of it. So you'll get the number of minutes that time period has elapsed. So here, 13 divided by 5 is 2. 2 divided by 4, we would like to be 1/2, but it rounds down. In this case, is 0. But if either one of them is a float or a double, and you can change these by saying, oh, I'm going to make them 0.0, meaning that this is going to be interpreted as a double, then what will happen is called upcasting, meaning that the result will be a double. So it won't do integer division anymore. And this is actually useful sometimes as well. So if you have a long integer expression and you want to have a division that makes it become a double, then one technique that I've seen and I have used is if you have the integer here, just multiply by 1.0. It doesn't change the value, but it now makes it a double. So, so if you want integer division sometimes, then make them both integers. If one of them is floating point or double, or if either one of them is, then the entire result will be a float or a double. Any questions on how that works? Okay, the one that I mentioned I would talk about. Sometimes you want to actually know what the remainder is of something. So, for example, if you do 9% 2, this is the remainder when 9 is divided by 2. So if I do the integer 9 divided by the integer 2, what should I get as output? 4, right? Because it's integer divided by integer. Well, what if I wanted to reinstate the number 9 by saying 2 times the result I have, which is 4? Well, what is 2 times 4? 8. Well, I didn't get 9, so why is there a 1 difference? It's the remainder. So if you want to know, if you were to divide this and see, well, there's some remainder left, how much remainder is actually left, then this is what the modulus operator will get you. So this will actually say, well, 9% 2, the remainder is 1. What's another proof of why this will give you 1? Yeah. Yeah, so that's one way to think of it. But what if I had an arbitrary number, like some variable here, and I did, say, x% 2. X is a variable, some integer variable, and then I do percent 2. What should that tell me? Yeah. If it's odd or even. So another proof of why this displays 1 is that because 9 is odd, it gives you 1. If it was even, that means that it divides 2 cleanly, so there's no remainder at all. So if I did, for example, 8% 2, what should it give me as output? 0, because there's no remainder. So this is a great way to figure out, well, what is the remainder if you were to divide this number by 2 in this case, or any number at all? If you did 3, then the remainders could be 0, 1, or 2. If you did 4, 0, 1, 2, or 3. Great. And so I use percent all the time. But you have to use integers in both cases here, because if you have, although I guess you could, so this could be a great assignment type question, although I won't ask it. Implement a function that says, you can have a double and a double here, do the percent, and then figure out what the remainder is. So if you did the remainder here, it should give you 1.0, because that's what the remainder actually is. But if I did 9% 2.5, the compiler will complain that's not going to work. But you may think, well, we could redefine, if we wanted to, percent to mean this thing. So if I did 9 divided by 2.5, whatever that is, then there's some remainder there. Then I just figure out what the remainder is. But in C++, this is not valid. So you have to use both integers in this case. Any questions on how the percent operator works? Yeah. Yeah, they have to be both integers. Yeah. Great question. So in this case, if that was allowed, then 9 will be upcasted to be 9.0. But it doesn't work in this case. Yeah. Oh, sorry? Great question. So remember the time length example where we divided by the integer 60 to get the number of minutes? Do percent 60 in this case. Then that's the integer remainder. So if we figured out the number of minutes by dividing by 60, then we figure out what is the number of seconds in addition to that we didn't account for. That's the remainder. So if we did percent 60, that'll give us the remainder number of seconds afterward. One way that you can use this is, in my own research, what I do sometimes is I need to pick a value between, let's say, 0 and 10. But I want to generate it randomly. So I generate a random integer, but that could be between 0 and 4 billion or something like that. Then what I do is I do mod in this case. I do mod 10, meaning that whatever the result is, I'm going to take the remainder. So that it's going to give me a result between 0 and 10. And then I can use that result. So it's a random integer between 0 and 10. But we'll get to random stuff maybe like in a month or so. But yeah, that's how I actually use it. I pick a random integer and then I do mod some number to get me something between a range, and then I can use that. Other questions about this? We won't actually use this that much, I don't think, but it's good to know. So one thing that is kind of annoying about variables is that the fact that they can change, right? So if you have a variable x and a variable y, and then at some place you don't want y to change, so that you're modifying x, but in somewhere later in the code you actually misuse y in place of x, so you're modifying y by accident instead of modifying x, then what you actually wanted in that case is a constant, something that does not actually change. So it's just a variable that does not change when the program runs. So the way that you actually put this, denote this in C++ is put a const keyword. So it's a C++ keyword that you put in front of the type. So if I wanted, wow, my voice cracked there. If I wanted, well, America currently, so I'm not going to try to be political here, but America currently has 50 states, if you don't count all the territories, but 50 states here, and it seems like for the moment that number's not going to actually change. So I want an integer here, but I don't want that number to change, so I'm going to put const here. Another example is if you're trying to implement some application for a business, then if the business is like literally located in some place, then probably for a while the tax rate is not going to change very much. So one estimation of how much to charge for tax is to say, I want a constant that is equal to something. So I declare a constant, double in this case, and then the convention here is to use all caps. But you do not have to use all caps here. It's just convention to say, if you see this word and it looks all caps, it's probably a constant. Okay? Yeah, often often in uppercase letters. So yeah, it must be assigned, because if it was allowed to not be assigned right at the very beginning, some value, then if you try to assign it a value later, then the problem is, well, are you initializing the variable now, or are you trying to change the value now? So the C++ compiler just says, you're trying to change the value now. So you have to give it an initial value, either from some variable or just a literal like 24. You initialize it with some value right out of the gate. Yeah, so if you try to change it later, this won't work. And then obviously some benefits are that instead of putting these magic numbers, as they're called, everywhere in your program, like if you want to use this tax rate variable here, you don't have to put 0.0775. So the advantage here is that it becomes a lot easier to read. So if you look at, say, well, what is the purchase price, whatever the price is, times whatever the rate of tax is, then I know what the sales tax is. So instead of reading some numbers here, now I can say, oh, it's much easier to read. Okay, so that's one of the benefits here. And it improves maintenance because you don't have to worry about accidentally modifying this constant anywhere in the program. Another cool thing about constants is that because it's constant, the compiler can make an optimization by saying, oh, since it's constant, anywhere that this is used in the program, during compilation, it'll copy and paste that value at every single point that it's used. You don't actually see that happen, but it makes an optimization because you don't have to look up what the value of that variable is because it'll never change. Okay, so any questions on constants? Yeah. Okay. Other question? Yeah.
If you make it so you read, are you still in the moment and explaining what you're doing, or would that?
Great question. So, do you think this line of code needs a comment, the sales tax equals line? In my opinion, so this could go either way. So this is not like a black and white thing. So it's not like a comment must be put here or it must not be put here. I would argue that it's not needed because the names of the variables help document themselves. They're what are called self-documenting. But if you had something like x equals x plus y, well, what are x and y? It might make sense in that context of the program, but without giving you that additional context, then a comment might be warranted. So here I think it's self-documenting, but of course there's no harm or foul in putting more comments in. So if you feel doubtful about how many comments to put in, there's never anything wrong with putting more comments in. Yeah. So you could put your own constant in, but remember maybe like the third lecture, something like that, I showed you how to include from the standard library their definition of pi. Yeah, so I would recommend that way because it's more maintainable that way. I have like 4 comments. I couldn't hear you. I'm looking for useful comments because some other sections emphasize that you should put as many comments as you possibly can. Could that be a bad thing? If I put too many comments in a program? Why? Right, it becomes way less readable if you have a whole bunch of comments and then one line of code. So I try to advocate for useful comments to the programmer. So if something is not completely self-documenting, like x equals x plus y, then I would put a comment here. But if you have something like this, then in my opinion, I don't think that's necessary. But of course, this is a case-by-case thing. In some contexts, this might make sense. In some other contexts, it might not necessarily make sense. So it just depends on the context. Yeah.
Does the constant use the exact same amount of data as the variable?
Right. Yeah, good question. So constant doesn't modify the amount of storage that's allocated. All that happens is so there's a place in what your program allocates as memory for things that are constant. So instead of putting it in some place in memory, it puts it in some other place in memory to denote, hey, this thing is never going to be changed. That's all it does, yeah. We might discuss stack and heap, but not yet. Other questions? Yeah.
Is there a way to change constant after it's declared constant?
So the answer is yes and no. So so here's one thing you can do. You can't, although this is not true either, but I'll tell you a little lie. How about that? Because it's easier to understand that way. So you can't change tax rate in this case. So the constant here, tax rate, you can't change it. But you could assign tax rate to some other non-const variable. Okay? So you can assign tax rate to, I don't know, some double I call x. Okay? But you can change x. It's just it's not the same location as what tax rate is. So why I said that was a little lie, in C++, you can actually address any memory location that you want. And so you can actually, through some other path, you can actually change the value of tax rate. But we're not anywhere near that level of sophistication. So just assume that you can't change a const variable. Other questions? Okay, cool. Last slide in this set of slides, then we'll move on to if-else. So this should be pretty straightforward. Try to program in a way that people will want to actually read your code, because you could, for example, write your entire program on a single line, but it's definitely not preferred to be that way. So just try to make it look appealing. So of course, one thing that I like, and so everything in the C++ world is the subject of a lot of debate and contention. So one thing about that is highly debated is where to put the curly braces. So, and I'm not kidding. So just think, well, if you're going to have a curly brace, open curly brace somewhere, have the corresponding closing curly brace matched up in your program. If you need to indent, then you should have them matched there. If you need another indent, match them there. So just try to match everything. C-Line does a good job at this, but it doesn't work in all cases. Okay, any questions about this? Before we get on to more cool stuff, yeah. Yeah, so we're not going to explicitly take points away, but it's just a general piece of advice to make it easily readable, because one thing that haunts me a lot of the times is because I write programs for myself, for my own research, I don't really put comments in my program. Then I come back 6 months later, and then I think, what in the world was I thinking? So that'll happen to you if you don't put comments or make it easily readable. So don't do what I do. Put comments in your program to make them readable. That's all I'm saying about that. Okay, so let's get on to decisions. So one thing that is kind of plaguing us at the moment is the programs that we've built so far are completely straight-lined, completely procedural, which means that it starts at the top of main and then it just goes straight through until the bottom of main. But you may wonder, well, what if I wanted to do some bit of code that is dependent on what the user inputs? So maybe if you want to have a, I don't know, what should you wear for today type of application because of the weather? Well, the user may have to enter what is the temperature today, and then they enter maybe 95 degrees Fahrenheit. Then you may want to output, you should probably wear shorts and a shirt. Then depending on whether the user enters some lower value, then you may want to output something else. Okay, so you may want to have conditional code. If something occurs, if something is satisfied, then you execute this block of code. If something else happens, then you execute this block of code, something else, then this block. Then you may want to make a decision of what to do there. So before we get into that, we need to talk about something called relational operators. So relational operators are basically a way of getting a Boolean value from comparing two things. So for example, if I wanted to check whether a number was at least some other number, then I would just say, is this number on the left greater than or equal to the number on the right? Then let's just say we have 95 here and 90 here. So what should that give me? It should give me true. It's going to give me true or false, but in this case it's true. If I had 95 on the left and 100 on the right, what should it give me? It give me false. Good. So each of these is just a comparison between two different things, and then it'll give me a true or false value depending on what the case actually is. So this is just a rehash of what I pretty much gave by that example. So 12 is strictly greater than 5, that's true. 7 is less than or equal to 5, that's obviously false. Then if x is some value, then you can see true if it's equal to 10. So here we have a double equals. So single equals is for assignment. So 2 equals means we're trying to check equality here, because I need to be able to check equality. This exclamation mark equal, that means not equal. Okay? So the exclamation mark just means not and then equal on the right. But double equals means comparing equality. So you can assign this to a Boolean value, although this is, I hardly ever do this. We use this for something called an if statement that we're going to see in a second. Yeah. So you can actually use 0 and 1 in place of true and false, but you don't actually have to here. Okay. So if you want, so if you want to evaluate, well, I have an expression that involves different comparison operators, which one is going to be executed first, then what's going to happen is if you have these, then they're going to be executed left to right, although that's not really true, but think of it as left to right. And then once those are all done, then the lowest precedence will be considered next. Okay? So although you hardly will ever encounter something like this, because we'll have other operators to separate these, but it's just good to know. Okay, so here's the big topic that we're going to see. So an if statement is if something is true, then we're going to execute this code. That's all it really is. So it allows statements to be conditionally executed or skipped over. So if it is cold outside, wear a coat and wear a hat. So what is the condition in this sentence that we're trying to check? Yeah, if it's cold outside, right. So it is cold outside. That is either true or false. Whatever the case is, if that is true, then we will wear a coat and wear a hat. But if it is not cold outside, will we execute this rest of the sentence, wear a coat and wear a hat? No, we only execute it if the condition that we're looking at is evaluated to true. So if it actually is cold outside, we will definitely do this. If it is not cold outside, we definitely will not do the rest of the sentence. But translated to C++, this just looks like this. So if we have if, then parentheses, some condition, which evaluates to a Boolean value, then with, I guess, optional curly braces, although that's not really true. A lot of things that are not true. Then if the condition evaluates to true, then these end statements in the inside the curly braces will be executed. Okay? So yeah, so if there's only one statement in here, so if n equals 1, then you can omit the curly braces, but I would definitely not do that. So a way to look at this is as a flow chart. We look at the condition. It's either true or false. If it's true, we execute the statements within the if statement. If it's false, then we just skip over the statements and then continue after when the if block of code actually ends. Okay? So just as an example. So if some integer score, or maybe double, I don't actually know, is at least 60, then we print you passed. If score is strictly less than 60, do I print this line? No. So if score, in this case, is at least 90, maybe we will assign some variable, some value. We don't necessarily just print stuff. We can have any amount of code that we want inside an if statement. Okay, so let's actually do an example. So let's revert this back to what I had before. So I have this little application that I want you to help me build. So this is not the grade distribution of the class, it's just an arbitrary grade distribution. So anything that's over 90 is an A, anything at least an 80 is a B, 70 plus is a C, 60 plus is a D, and anything else is an E. Well, so the code I have so far, what does it do? It prints something to the user, and then it inputs the score. So what should I do here? I want to conditionally print A, B, C, D, or E, depending on what the case is. So what should I do? Yeah?
If score is greater than or equal to 90.
Right, so if score is greater than or equal to 90, then I always put curly braces to be safe. But and I'll discuss why that is. But okay, so if that's the case, what should I do in that case? Right, see out you've gotten an A, or just to save time and space, I'm just going to print A. Then what should I do here? So if I do score greater than or equal to 80, then I should see out what? C. I should print out B. Good. So let's just see what happens. So let's just say we got a really good score. We got 95. Oh, we got an A and a B. What happened?
You did not like consider like all of the cases, like if A is greater than or equal to 90, all is less than all equal.
Well, let's see. Let's just step through the program and just see what happens. Score is 95 here. Is score 95 at least 90? Yeah, so we print A. Is score at least 80? Yes, so we print B as well. So how can we get around this?
If score is equal to 90, equal to greater than equal to 90, but not greater than, but not less than 90, then print A.
But if it's at least 90, it's definitely not less than 90. Use an else statement. So let's talk about else statements. I guess I have to skip a little bit. I guess I'm going to be skipping and I'll come back next time. So an else statement just says, if the condition's true, you do the code corresponding to the if statement. Else just means if the condition was not true, then we go on to the next bit. Okay, so if condition is false in this case, which of the statements am I going to execute? 1 or 2? If condition is false, 2, right? Because it's just you do this if the condition's true, you do the second statement if the condition is false. So going back to our example, if I put an else here, this says, well, the else corresponds to it is not at least 90. But then we do an additional check here if the score is at least 80 also, which means it's between 89 and 89.999 whatever and 80. So let's just see what happens if we look at this now. So if we do 95 again, it prints A. So we're just saying, if it's not the case that it's the first one, then we do the second one, but now we have an additional check to do. Is there a way that I could, good question for thought. Is there a way that I can make this program without else statements or other comparison operators? I could, but I haven't covered that yet. Yeah. Yeah, but the issue there is if you do the greater than or equal to there, you're still going to have the same issue. It's just going to be printed in the backwards order. So a good question for that. I'm not actually sure if you can. Yeah.
You can literally define everything from 0 to 100 and what
There it is. Yep, exactly. So I can define 100 const variables and then just do 100 if statements to check, is it equal to this one, equal to this one, equal to this one? And then at no point am I going to have the value that's inputted here to be equal to 2 different integers. The only issue here is that I have a double. So I don't have 100 integers to work with, but many, 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 many more. Okay? But if I had an integer, you're absolutely right, you could do that. Yeah.
if the score is greater than or equal to 80 and
Yeah, I haven't covered and yet. That's another way you can do it too. See, things I didn't even think of. What if I put a return 0 here? Then return 0 means the program stops executing, you stop from main. Well, if I get into this statement here, then I print A and immediately stop. So that actually accomplishes what I actually want. Okay, and then I can do the same thing for C, for D, and then finally for E. Other questions? Okay, so I'll see you on Friday.